Let's look at a few examples involving conic sections of ellipses, and we want to look at them where they are no longer centered at the origin. So they've been shifted vertically or horizontally in some direction to some amount. Okay. In our first example, we want to sketch the graph, and we want to write the standard equation for the ellipse. Its center is at 2, -1. It has a vertex at 2, 3, and its focus, one of the foci, is at 2, 2. So let's start by plotting those points on the graph and see if that will help us figure out what the ellipse actually looks like. And then from there, we can figure out the equation. So I know the center is at 2, -1. That's our center. I know that the vertex is at 2, 3. And one of the foci is at 2, 2. Okay. So just like we saw with parabolas, an ellipse is always going to curve around the focus points. Okay. So if the focus point is at 2, 3, if the vertex is at 2, 3 and the focus is at 2, 2, then the ellipse has to pass through the vertex and curve down around the focus. So it's going to curve, at least right now, I know it's going to curve sort of downwards in that direction. Okay. But to figure out the full ellipse, I need to figure out the bottom part and the width of this ellipse. Okay. So the nice thing is that the center obviously is in the middle of the ellipse. So if I know where the center is and I know where one of the vertices are, I can find the other vertex just by looking at the distances. So if the center is at 2, -1 and the vertex is at 2, 3, that's a distance of 4 units apart. From -1 to 3 is a distance of 4. So that means the other vertex is also 4 units away from the vertex. Since one vertex, the one we're given, is above the center, I know the other vertex has to be 4 units below the center. So 1, 2, 3, 4. So the other vertex has to be at 2, -5. Okay. I also know that the foci are the same distance. Each one is the same distance from the center. The foci we're given at 2, 2 is 3 units away from the center, which means the other foci is also 3 units below the center. So that would be at 2, -4. So just looking at what we've plotted so far, we have graphed 5 points. The center, both foci, and both vertices, they are all along a vertical line. Okay, and that vertical line from one vertex to the other would be the major axis, and that line, that major axis, is a vertical line. And so that means that in this case, I have a vertical ellipse. Okay. A vertical ellipse means that the y value is stretched more than the x value. And so my general equation is going to be x minus h, quantity squared, divided by b squared, plus y minus k, quantity squared, over a squared, is equal to 1. So again, the a goes with the y, and the a is in the denominator of the y fraction because it's a vertical ellipse, and y is our vertical variable. Okay. I already know that a is the distance from the center to the vertices, which is a distance of 4. I don't know b yet, and we're going to need to find that to write my equation, but I do know c. C is the distance from the center to the foci, which we already saw was a distance of 3. So if I know A is 4 and I know C is 3, how do we find B? Well, I already have that equation that we've seen before. C squared is equal to A squared minus B squared. So plug the 4 in for A, the 3 in for C, and we'll solve for B. So 3 squared is 9. A squared is 16, so we have 9 equals 16 minus b squared. If we add a b and subtract a 9 from both sides, we'll have b squared is equal to 7. Right, 16 minus 9 would be 7. And then so b is going to be the square root of 7. So b is the square root of 7. Now just to kind of give us a little bit of context, the square root of 7 is roughly about 2.6. So it's about 2.5, 2.6. So that's going to tell me kind of how wide our ellipse is going to be. So it has to travel from the center about 2.6 to the units to the left and the right. So if the vertex is at 2, -1, then we're going to travel 2.5 units to the left and 2.5 units to the right. And so we can kind of see our ellipse is going to look something kind of like that. Okay, it is taller than it is wide, so it is vertical. And so now we can go ahead and finish writing our equation. We have the graph sketched already. We now just need to write our equation. So the center, where's the center? It's at 2, -1. So we're going to have x minus 2 quantity squared divided by 7 plus y plus 1 quantity squared divided by 16, and that is all equal to 1. Again, the 7 is the b squared, so square root of 7 squared is 7. The 16 comes from a squared, so 4 squared is 16. It's x minus 2, because the x coordinate is a positive 2 for the center, and it's y plus 1, because the y coordinate is a -1. So that is the equation for the ellipse, whose center is at 2, -1, its vertex is at 2, 3, and a focus at 2, 2. Okay, and that's a vertically oriented ellipse. All right, let's try and look at another example. This time we're given the graph of an ellipse. So from this graph, we want to identify all of its key characteristics. So we want to figure out the location of the center. So we want to know the center. We want to know the vertices. We want to know the co-vertices. We want to find the foci, the length of the major axis, the length of the minor axis, and the eccentricity. Okay. So let's start just by looking at the graph. This graph is wider horizontally than it is tall vertically. So that means that this is a horizontal graph. So it is oriented horizontally. So when we write the equation for a horizontal ellipse, the a, which is the bigger denominator, it goes with the x. So we're going to have x minus h squared divided by a squared plus the y minus k quantity squared over b squared, and that's equal to 1. Okay, so to write the equation, I need to find the center, which is the h and k value, and then I need to find the a and the b value. Okay, and I'm going to need all of those to figure out all of my key characteristics. So let's start with our center. So if you kind of just look at where the shortest distance and the longest distance of the ellipse intersect, that's going to let us locate the center. So in this case, the center is at the coordinate 1, 4. Okay, so then we could figure out our vertices. The vertices are the 2 points furthest away from each other. So again, this is a horizontal ellipse, so it's the furthest left and the furthest right point. One vertex is at -4, 4, and the other vertex is at 6, 4. The co-vertices are the shortest distance. So in this case, that would be the two vertical, the top and the bottom point of the ellipse. The co-vertices are going to be at 1, 2, and at 1, 6. It doesn't matter which order you list all these points. I usually just list the smaller value first and then the bigger value second. Foci, let's put a pin in that and come back to that because we need to do a little work to figure that out. The length of the major axis, since this is a horizontal oriented ellipse, it is the horizontal distance from one vertex to the other. If one vertex is at -4, 4, and the other is at 6, 4, how far is it from -4 to 6? Well, that's a distance of 10 units. The minor axis is the distance from the co-vertices. So if one is at the coordinate 1, 2, and the other is at the coordinate 1, 6, how far is it from 2 to 6? It's a distance of 4. And so this graph is 10 units wide and 4 units tall. All right, so we still need to find the foci and the eccentricity, and we still need to finish writing the equation of our ellipse out. To do all of that, we need to know the values of A, B, and C. Okay, A is always the distance from the center to one of the vertices. So how far is it from the center to one of the vertices? So the center is at 1, 4, and there's a vertice at 6, 4. So how far is it from 1 to 6? That's a distance of 5. And again, you could count that on the graph if you want. So 1, 2, 3, 4, 5. So it's a distance of 5 units horizontally. B is the distance from the center to one of the co-vertices. And that distance, there's a distance of 2. Okay. Because the co-vertices are 4 units apart. So that would be a distance of 2. And same thing, the major axis is a length of 10. So the A value is half that, or 5. To find C, well, again, we know C squared is A squared minus B squared. So C squared is going to be 25 minus 4. C squared is going to be 21. So C is the square root of 21. And we can't really simplify 21 using perfect squares. So C is the square root of 21. All right, so let's write out our foci, and then we will figure out the eccentricity, and then we will write out the equation. So the foci, we want to find the center, and then the foci are each a distance of C away from the center. And since this is a horizontal ellipse, that C value is going to change the x coordinate. Okay, so the center, we already said, was 1, 4. So one of those foci is going to be at 1 minus the square root of 21, 4. And the other one is going to be at 1 plus the square root of 21, 4. And again, the reason I'm adding and subtracting the square root of 21, the C value, to the x coordinate is because we have a horizontal ellipse. Okay, that the foci have to be on the same horizontal line as the center and the vertices. All right, to find the eccentricity, remember the eccentricity is C over A. So we're going to have the square root of 21 divided by 5. And if we just compute that on our calculator, we'll get roughly 0.92 if we round it to 2 decimal places. Okay. So again, having a value closer to 1 means that this ellipse is stretched more in one direction than it is another. The closer to 0 would mean that we have more of a circle. All right, we have everything we need, all the key characteristics. We just need to write the equation of our ellipse. So the h and the k come from the center, and then the denominators a and b come from our a and our b values. So we're going to have x minus 1 quantity squared divided by 25 plus y minus 4 quantity squared divided by 4, and that's equal to 1. So again, remember the x minus 1 and the y minus 4 come from the center coordinates of 1, 4. The 25 comes from 5 squared, the 4 comes from the 2 squared, and the 25 goes under the x because this is a horizontally oriented ellipse. All right, let's look at one more example. This time we're given more of a general equation for ellipse. It's not in the standard form, but we want to write it in standard form. And then we also want to figure out all the key characteristics. Okay. To do all the characteristics and sketch the graph, we need to first get it in standard form. And that's going to involve completing the square, and we're going to have to do that twice, once for the x and once for the y. So the equation that we're given is 4x squared plus 25y squared plus 8x plus 150y plus 129 is equal to 0. So to complete the square, let's kind of group the x terms. Let's group the y terms. And then anything that doesn't have an x or a y, any constant terms, will move to the other side of the equation. So I'm going to have 4x squared plus 8x, there's the x terms, plus 25y squared plus 150y, and that's going to equal a negative 129. In order to complete the square, the squared term must have a coefficient of 1. So there can't be anything directly in front of the x squared or the y squared term. Which in this case, I have a 4 in front of the x squared and a 25 in front of the y squared. So to kind of work through that, we need to factor the 4 and the 25 out of the x's and the y's. So I'm going to rewrite 4x squared plus 8x as 4 times the quantity x squared plus 2x. Okay, the 4 is still there, but I factored it out of the x squared and the x term. I'm going to do the same thing with the y. So I'm going to factor a 25 out, and that's going to leave me with y squared plus 6y. And all of that's still equal to a negative 129. So now we can go ahead and complete the square. So we're going to have 4 times the quantity x squared plus 2x plus the number we need to complete the square. And that's all one quantity. Then we're going to have plus 25 times the quantity y squared plus 6y plus the value we need to complete the square for the y's. And all of that will equal a negative 129 plus the values that we added to both sides of the equation. Okay, so to complete the square with the x's, take the number in front of x, which is a 2, divide it by 2, and then square it. So 2 divided by 2 is a 1, and 1 squared is a 1. So that means I'm going to have 4 times x squared plus 2x plus 1. We do the same thing with y's. So this time it's a 6 in front of the y. So 6 divided by 2 squared. 6 divided by 2 is a 3. So 3 squared is 9. So my y's are going to look like a y squared plus 6y plus 9. So on the left side of the equation, I have 4 times the quantity x squared plus 2x plus 1 plus 25 times the quantity y squared plus 6y plus 9. And then all of that is going to equal a negative 129 plus whatever I added on the left side. So for the x's, I added a 1 inside the parentheses, but that parentheses is multiplied by 4. So I technically added in a 4. For the y's, I added in a 9, but what is 9 times 25? That's going to be 225. So I'm going to have on the right side a negative 129 plus 4 plus a 225. Okay. So let's simplify this a little bit. With the x's, we have x squared plus 2x plus 1. That factors as x plus 1 quantity squared. So I'm going to have 4 times x plus 1 quantity squared plus 25 times y plus 3 quantity squared. And that will equal, if I combine everything on the right side, that's going to simplify down to 100. Okay. When we write the equation of ellipse, we want the whole thing to equal 1. So I need to take every term and divide it by a 100. Okay. So the 4 and the 100 reduce down to a 25. So we're going to have x plus 1 quantity squared over 25 plus a y plus 3 quantity squared over a 4, and all of that is equal to a 1. Okay, so I have simplified the general equation that we were given. I've rewritten it in its standard form. From that standard form, we can then figure out the values for A, B, and then we can use that to figure out C. And then once we figured out the A, the B, and the C, we can go ahead and sketch the graph, and then we can list out all of our key characteristics. So again, the key characteristics that we're looking for are the center, the vertices, the co-vertices, the foci, the length of the major axis, the length of the minor axis, and then the eccentricity. Okay, so let's start with A, B, and C. So A squared is the larger denominator. So in this case, the bigger denominator is 25, and 25 is 5 squared. So A is 5. B is the other one. So 4 is B squared, which means B is 2. And so we need to find C. So C squared is equal to A squared minus B squared. C squared is equal to 25 minus 4. So again, C squared is going to be 21. So C is going to be the square root of 21. All right, so now we need to figure out all the key characteristics. So looking at our equation, we have x plus 1, which means the x coordinate is a -1. And then we have y plus 3, which means the center is a -3. So the center of this ellipse is -1, -3. The vertices are always a distance of A from the center. Now, is that vertical or horizontal? So looking at our denominators, 25 is the bigger denominator, and that is 25 under the x. And so because of that, I know that this has to be a horizontal ellipse. If it's a horizontal ellipse, that means the vertices are to the left and the right of the center. So I need to travel from -1, -3, 5 units to the left and 5 units to the right. So the vertices are going to be -6, -3, and then it's going to be 4, -3. So that's left 5 units and right 5 units. The vertices, or the co-vertices, are going to be 2 units vertically, 2 units above and 2 units below the center. So that's going to be -1, -5, and then -1, -1, because those are 2 units above and below the center. The foci are going to be a square root of 21 to the left and to the right of the center. So that's going to be a -1 minus a square root of 21, -3. And it's going to be a -1 plus the square root of 21, -3. And again, I'm only adding that in the x coordinate because this is a horizontal ellipse. The major axis is 2 times a, because this is a horizontal ellipse. So the major axis is going to be 10. The minor axis is going to be 2b, which is 4. And the eccentricity is going to be a square root of 21 over 5. And again, that doesn't really simplify, but we can go ahead and compute it. That's going to roughly be a 0.92. All right, all that's left is to sketch this ellipse. I know the center is at -1, -3. The vertices are at -6, -3, and then at 4, -3, which those should each be 5 units away from the center. So just double check those and make sure they're 5 units to the left and to the right of center. The co-vertices should be 2 units above and below. So -1, -1, and -1, -5. And then we can go ahead and just connect those 4 dots. So we're going to go around, connecting the 2 vertices and the 2 co-vertices, and the center should be in the middle of all